All right, let's just dive right into this. Welcome to This Explainer. You know, if you've been paying any attention to the tech world recently, you already know that the past 12 months in robotics have been, well, absolutely wild. I mean, the advancements we've seen are borderline scary at this point. We are literally witnessing an explosive evolution right before our eyes, shifting away from those clunky, lab-bound prototypes to truly agile companions that are actually ready to step out into the real world. So, it's a completely valid question to ask, how on earth did we get here so fast? How did we transition from robots that could barely walk across a room without a safety tether to autonomous androids that can think, learn, and move with this uncanny grace, all in just a single year? Well, a huge piece of that puzzle comes down to one fundamental engineering shift that is completely transforming the entire industry.
Think about the traditional Boston Dynamics Atlas robot for a second. The older models relied heavily on traditional hydraulics. That meant they were incredibly noisy, packed with intense mechanical complexity, and wrapped in heavy protective plating. Frankly, they were kind of intimidating. But now, we're seeing a massive shift to modern electric actuator designs. High-pressure hydraulic fluids are out, and vastly quieter, beautifully streamlined, completely cable-free electric motors are in. And a huge, absolutely crucial bonus here is safety. Moving away from the high-pressure, complex systems of hydraulic machines makes these new electric robots so much safer to actually operate right alongside humans.
Now, this isn't just a minor upgrade, it's a total paradigm shift. As the source material brilliantly puts it, this transition is like Bob Dylan famously switching from acoustic to electric guitar. I love that comparison because it really humanizes the engineering leap. Electric actuators don't just change how the robot gets its power, they fundamentally change how the robot moves and interacts with its environment. It basically sets the stage for everything we're about to talk about.
To really grasp what those custom, high-powered electric actuators can do, just look at how Boston Dynamics revealed the new electric Atlas. It starts out completely flat on its back on a gym mat, but instead of awkwardly rolling over to get up, its legs bend at the knees in a way that feels almost alien, honestly. It stands completely upright and then smoothly rotates its head and torso a full 180 degrees. That fluid agility proves for sure that electric motors can provide the raw power and extreme flexibility of an elite athlete.
Section 1. Precision in the Factory, the Dexterity Upgrade.
Okay, so raw power is great, but what the industry really needs right now is finesse. These new electric actuators dramatically improve precision for complex factory tasks, things like intricate assembly and lifting. Take Tesla's Optimus Gen 2, for example. Its hands feature 11 degrees of freedom and this amazing tactile sensing skin that can actually feel pressure and temperature. Then there's the Unitree G1, which has such incredible fine motor skills it can literally crush a walnut, or do highly delicate tasks like soldering electronic components. Meanwhile, Sanctuary AI's Phoenix robot boasts an expanded range of motion in its wrists and elbows that is explicitly designed to mimic actual human dexterity.
But here is a number that should really make you stop and think. $16,000. That is the starting price for the Unitree G1. Just a few years ago, advanced bipedal research robots were running upwards of $150,000. This shockingly affordable price tag just emphasizes how rapidly this advanced technology is becoming accessible. It means smaller labs, universities, and local businesses can now afford hardware that was completely out of reach just a minute ago.
And the crazy part? They aren't sacrificing quality for that lower price. The G1 uses something called hollow joint technology. This basically internalizes all the wiring right inside the robot's limbs, enabling hyper-flexible and highly efficient movement. But what's even more staggering is its extreme impact stability. You can literally deliver a solid punch to the G1's chest, and it effortlessly maintains its balance without any external support cables at all. In a busy, unpredictable factory or warehouse setting, that kind of physical resilience is absolutely essential.
Meanwhile, Sanctuary AI is pushing the software side of things forward at a blistering pace. By partnering up with Microsoft Azure, they are pouring massive computing power into developing large behavior models, or LBMs. But the most staggering fact here, they've actually managed to slash the time it takes to train a robot on a completely new complex automation task from several weeks down to under 24 hours. Under 24 hours! That is a 50x increase in automation speed, which is just a total game changer.
Section 2. AI brains meet robotic brawn.
So having these agile, electric bodies is fantastic, but it's really only half the battle. These machines need sophisticated minds to match their brawn. And this brings us to a vital concept called embodied AI.
Unlike a standard chatbot that just lives on your computer screen, embodied AI is artificial intelligence designed specifically to interact with, learn from, and adapt to the messy, totally unpredictable physical environment in real time. It's all about giving a robot true human-level awareness of the actual physical world around it.
To see how this actually works in practice, let's talk about a company called Covariant. They are taking the exact same neural network architecture that powers text-based AIs, like ChatGPT, and they're linking it straight up with robotic camera sensors. This setup allows the robot to digest spoken English instructions, literally look at its surroundings, and then manipulate physical objects it has never explicitly been programmed to handle. For instance, you could tell a Covariant robot to pick up the banana, and even if it has never seen a banana before in its life, it can combine its digital training with its physical sensors to identify and sort it.
Section 3. Entering human-centric spaces. Because modern electric actuators are so incredibly quiet and efficient compared to the old hydraulics, these machines are finally able to leave those noisy factory floors. They can now integrate perfectly into human-centric spaces, like our offices, warehouses, and even our homes. Companies are deliberately designing robots to take on complex service roles as approachable, non-intimidating companions. Take LG's adorable, foot-tall moving smart home hub. It wanders around, checks the temperature, keeps an eye on your pets, and get this, it can even read your facial expressions to play music that matches your mood. Then you have Leica, an AI-powered robotic space dog designed specifically to comfort astronauts. It uses 3D printing covered in soft materials and actual fur so it feels natural to interact with, completely avoiding that cold, Terminator-style aesthetic.
So what we are witnessing right now is a real divergence in robotics. On one side, yes, we still have the industrial utility, the heavy lifting, the manufacturing, dealing with dangerous waste materials. But on the other side, these electric motor advancements are enabling robots to step into roles focused on daily harmony. We're talking about robots doing household chores, assisting with elderly care, reading our moods, and genuinely providing companionship in our everyday lives.
Section 4. The promise and the peril.
Of course, we have to be real here. Integrating highly advanced, embodied AI into our daily lives isn't without some massive challenges. As we hurtle toward the potential creation of artificial general intelligence, an AI that matches or even exceeds human cognitive abilities, we have to confront the peril. As the source material plainly states, the existential risks of an unaligned, super-intelligent AGI simply can't be overstated. If we build a super smart brain and put it inside a highly capable, highly agile physical robot, we absolutely must ensure that its goals and ethics align perfectly with humanity's safety.
And right now, there are some pretty alarming claims coming from inside the industry itself. Recently, whistleblowers at OpenAI raised serious warnings. They allege that companies are recklessly rushing toward AGI supremacy, driven by pure competition, ignoring their own internal safety review processes, and actively deprioritizing vital safety work. Furthermore, they claim that employees are being muzzled by strict non-disparagement agreements, preventing them from speaking out. Now, regardless of where you stand on the issue, these claims really highlight an intense internal conflict over exactly how to responsibly manage this world-altering technology.
Which leaves us with this final, profound thought to take away from this explainer today. The engineering hurdles are being cleared, the shift from hydraulic to electric mobility is basically complete, and the AI brains are rapidly getting smarter by the minute. But as these incredible technologies merge together, the real question is, are we, as a society, actually ready to harmoniously coexist with machines that can think, feel, and move just like us? It's a fascinating, perhaps slightly terrifying frontier, and it is happening right now. Thank you so much for joining me as we explored this incredible material.